Today's lesson is 5.1, Graphing Square Root Functions. Previously, we have talked about the quadratic function and how to graph it. When we go ahead and we have our function f of x and we add some value d to it, what we do is we move our graph up d units. Every point on my graph is then shifted up those same d units, and the x value stays the same, and we simply add d to the y values. So take a look at our two functions here. In blue, we have our parent function, y equals x squared. That's my parent parabola. And we see the graph there. And the red one is my transformed function, y equals x squared plus 2. So notice that we went from 4 to 2, but the y stayed the same. We went from 1 to 3, but it stayed the same. And it happens every time. At each and every y value, we simply add 2 to it. Okay, my domain is my x values. So think about taking the blue function and simply laying it across the y-axis, or sorry, the x-axis. And it would lay from end to end. There would be no stopping it. There would be no end to it. So we, in interval notation, we call this negative infinity to positive infinity. And remember, we use our parentheses because infinity is not a definite point. Okay, it's not included. My range is my y values. My range is my y values. So I'm looking at my blue graph here along the y axis. However, my blue graph is not down here in the negative parts. It starts right here at 0, and it would smush into the y-axis and continue upward towards the infinity. So once again, I have positive infinity, but I don't have negative infinity. I'm actually starting at 0, and I'm going to positive infinity, okay? The domain for my transformation, the red one where I've added the 2 to it, the domain is going to stay the same. I can take that red graph, and if I move it to the x-axis, it's going to just go all real numbers negative to positive infinity. But you start to see a shift here in the range. My range now is taking not only out the negatives, but it's also taking out this chunk of numbers right here in the positives. So it's going to start right here at 2 and then continue upward to positive infinity. So my range would be 2, comma, infinity. We also talked about how the transformations work when we look at our formula, okay? When we look at our function, when we look at our equation. So this a value that we see in front of our parabola, our x squared value, it indicates a reflection across the x-axis. And of course, this happens when it's negative. So if my a is negative, I'm going to see a reflection across the x-axis. Or it could also do a vertical stretch or compression. Okay, it could do both, just depending on if it's a number or not. H, the number inside with my X, is going to indicate a horizontal translation. Remember, a translation is simply a movement. So we're going to pick the graph up and we're going to move it. Horizontally means we're going to move it to the left or to the right. Also remember that because it is inside the parentheses, this minus is very deceiving. I would think that the minus would move the function to the left, but because it is inside and we are squaring it, but just mainly because it is inside the function, it actually does the opposite. So this would actually move to the right, okay? A minus would actually move to the right, and a plus would actually move to the left. Okay, so just be careful. Remember, H is tricky. Right is minus, left is plus. The last one we have is our K. at the end, and it indicates a vertical translation or a movement up or down. This one is not being tricky. This one is not being tricky because it is outside of the function, outside of the parent function of the square in this case, and up is going to be positive plus and down is going to be minus. Same thing, okay? All right, let's go ahead and take a look at our square root parent function. This is f of x equals x squared, and here it is in our graph. Notice that this graph is half of a parabola laying on its side. For my function f of x equals the square root of x, my output y is the same as the input x of f of x equals x squared. My domain and range for this square root function are all real positive numbers, including 0, because it is touching right here at 0. And x, of course, cannot be negative because you cannot take the square root of a negative number. We just saw that in complex numbers. If we take the square root of a negative number, we get an imaginary number. Okay, so when we're graphing, we cannot graph the imaginary part, so we just say it doesn't exist. Okay. Hence, by limiting the domain of my f of x squared to x is greater than 0, it is the inverse of my function f of negative 1x equals x squared. So basically what I'm trying to tell you here is that this graph that you see, this function that we are going to graph in blue and this function that we are going to graph in peach are going to be inverses of each other. They're going to be inverses of each other. Let's go ahead and take a look. Let me get the peach there. All right, so we're limiting my f of x function to be greater than or equal to 0 for my x values. So when I plug in -2, even though I could give you a value for it, I'm going to have to say it is undefined because I have limited your x's for you. I've limited your domain. Likewise with -1, I have undefined when I plug in -1 into x squared. Now, because my x can be greater than or equal to 0, now I can actually start substituting in these numbers. So I get 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. Let's go ahead and graph what we can of that function because I only put a 10 by 10 graph. 2, 4, 3, 9. There is my parabola. Now remember, this is only one side of it. It actually does have a part coming over this way as well, but we're restricting it right here so that we can see that it is that the other function, the f of the y equals x squared, is a inverse of it. Okay. All right, let's go ahead and take a look at this one. The peach function, y equals x squared. So when I plug in -1 in and take the square root, I get I, the imaginary number. So I'm going to go ahead and say that's undefined because I cannot graph that imaginary number I on my graph. This is not an imaginary graph. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. And the square root of 16 is 4. Okay, I can go ahead and graph those numbers. 4, 2, 9, 3, and I cannot do 4, 16, but you get the idea. There's what it is. There's what they look like. So it's not necessarily how they look, it's what's happening in the table that makes them inverses of each other. Now, if you take, we have to go ahead and take these ones out because they are undefined. So we're not even going to look at those. If you take a look at these 2 points, they match exactly over here. So, okay, it's not that they match, it's what's happening in these points right here and these points right there. Notice that I see 2 4, and then I see 4, 2. Did you see what happened? 3, 9, 9, 3. And it happens at every point. 4, 16, 16, 4. What's happening and what is making them inverses of each other is that the x value and the y value are simply switched from one to the other. That is what is making them inverses. So what is happening right here and right here, that's what's making them inverses. It's also happening at 1 and 1, but it's kind of hard to see that this one goes and becomes that one, right? And this one is this one, because 1 and 1 is the same, and the same for 0. Okay, but that's what's making them inverses. I'm simply switching the x and the y value. Let's go ahead and practice finding our inverse function. So here are the 4 steps to making an inverse function. You're simply going to stick y in for f of x. So if you see any kind of function notation, f of x, g of x, h of x, those are very commonly used, you're going to first replace that with the variable y. Next, you're going to switch your x and your y, okay? Because whenever I have an ordered pair, x comma y, to get its inverse, I simply switch them to y comma x, and this becomes my inverse. If I have an equation, step 3, I need to solve for y. So I need to solve for my new y. I need to move everything and I need to algebraically solve. And then I need to stick it within my inverse function notation, which is f to the negative 1 power of x. This is my inverse function notation. Let's go ahead and give it a try. I've got 2 equations here for us to do, and we just have to find the inverse of both of these. So we're going to try a quadratic, and then we're going to go ahead and try a square root so that you can see that they are inverses of one another. So step 1, we're going to change the f of x to y. Okay, there's step 1. And now we're going to go ahead and we're going to do the inverse. So I'm going to write down the word inverse, because sometimes it can get a little bit confusing. I need to find the inverse, and I'm going to go ahead and change the letter y to the letter x and the letter x to the letter y, and there we go. Okay, now my whole goal is to solve for this variable right here. I want that variable, that letter, all by itself. So what's bothering it? Let's see, what's bothering it? The x is not bothering it because the x is on the other side. The square right next to it is bothering it, and the positive 6 is bothering it. If I follow my order of operations, I must get rid of the 6 first. So I'm going to grab this plus 6 and move it over here by subtracting. So let's subtract the 6. Now there is nothing to subtract the 6 from on the other side, so I'm simply going to leave it. Let's come back and look at our y. I keep highlighting it in the different color so that I can focus on it. What is bothering my y? The square. The square is bothering my y. And remember, always look at your equal sign. Anything that's moved to the other side is not bothering your variable y any longer. How do I get rid of that square? How do I get rid of that square? Well, I take its square root. What I do to one side, I must do to the other. So I end up with y, and I end up with the square root of x minus 6. This is all I can do. My y is now completely alone. So I'm just going to go ahead and I'm going to change to my inverse function notation. Make my square root look nice for you guys. This would be my solution. Okay? Notice I started with a quadratic. I ended with a inverse function that's a square root. That should always happen. You start with a quadratic, you end with a square root. Let's try the other one. F of x equals the square root of x minus 5 minus 2. Let's go ahead and change f of x to y. And then let's go ahead and do the inverse. Okay, so we're going to change y to x, and we're going to change x to y. Let me get that square root in there. There we go. All right, let's go ahead and highlight that y, because remember the whole point is we got to get that variable of y alone. So let's go ahead and take a look. What's bothering it? Well, not x. X is on the other side. There's a minus 5, there's a square root, and there's a minus 2. Since the minus 5 is underneath the square root with the y, I have to get rid of the minus 2 first. So I'm going to add 2 and move it over here with the x. So let's do that first. There we go. X plus 2 equals square root y minus 5. All right, now there are still two things bothering my y, the square root and the minus 5. Since the minus 5 is underneath the square root, PEMDAS says, the order of operations, says I got to get rid of that square root first before I can just add 5 to the other side. How do I get rid of a square root? Well, oops, I'm in the wrong color, sorry guys. I'm going to square it, because if I square this, I get y minus 5. Okay, which is exactly what I want, and now I can just add 5. But I got to be careful. What I do to one side, I have to do to the other. Now I have to be very super careful at this point, because do you see this right here? This actually means that I have x plus 2 times x plus 2. I have to multiply that. So I'm going to go ahead and use my box method of multiplication. And I'm going to change it to a lighter gray color here. I'm going to split it in half and put my x and my plus 2 on each column on the top. And then I'm going to split it from left to right, and I'm going to put my x plus 2 here. Remember, you're multiplying rectangles, so x times x is x squared. 2 times x is 2x. 2 times x is 2x. And 2 times 2 is 4. You're going to start just like you did when we did this with the complex numbers. You're going to start here. That's your starting point. This is your ending point, and these two are your like terms. And remember, the box tells you add them together. So on this side, I actually have x squared plus 4x plus 4. All right, what's bothering my y? That minus 5. Let's move it. Plus 5, plus 5. And notice I went ahead and put it right underneath that 4 because they are like terms. I am going to go ahead and add them together and say it equals 9. My y is now completely alone, and so I'm just going to go ahead and change it to my inverse function notation, which is f of negative 1x, and copy my function. Yes, it takes a little bit more time when it isn't an equation, but it is very simple to do. If I had a graph, if I had a table, all I would have to do is switch the x with the y value and plot my new points. I much prefer a graph, or I much prefer a table to find an inverse because it's faster. It's quicker. It's quicker to just switch the x and the y. This takes a little bit more time. All right, the last thing I wanted to talk to about today is the graphing. We finally are getting to the graphing. We are going to go ahead and use Desmos to help us out. When you get into your ALEKS equation, when into your Alex assignment, you are going to be asked to graph with 4 points. So we're going to go ahead and see that in just a moment. So it was the square root of x minus 2 plus 5. And there it is. There we see it on Desmos. Okay. You can still come in and use the table feature. We're still going to use that. We're going to go ahead and delete these points. What Alex is going to ask you for is the leftmost point. Okay, so Alex wants this point right here. Alex wants this point right here, the leftmost point at 2. It wants that one right there, 2 comma 5. And then it's going to ask for 3 more points because it wants 4 in total. The left point, leftmost plus 3 extra. So I have already gone ahead and figured out what these points are. 6 and 11. Okay. I would say just keep playing around with it. Take a look at your Desmos. You're going to want to put in equation numbers in your table for Alex that are not decimals. If you notice, after 3, I could have tried 4, but I got a decimal. So I'm going to want to delete that and not use that. I tried to use looking at the grid lines as much as possible. And then I just started putting in numbers. I could try 12 after this, but it's a decimal. 13, but it's a decimal. 14, but it's a decimal. 15, but it's a decimal. 16. And I could just keep trying like that, so on and so on until I find a 5th point. But Alex is only going to ask you for the 4. So there you go. Let's go ahead and go back. And those points were 2 comma 3, 3 comma, oh shoot, I didn't write them down. Let me see. 3 comma 6, 6, 7, and 11 and 8. Oh, I should have had that memorized, guys. I'm so sorry. 3 comma 6, 6 comma 7, 11 comma 8. Okay, so let's go ahead and plot them so we can see what this function looks like. There we go. Did I do that right? And then, of course, I can't quite get to the 11, so there we go. Okay. We still can do transformations on a square root function. Just like before, my a value is going to give me a vertical stretch or compression. And when a is negative, I am going to see that reflection across the x-axis. I could see a b factor right here. If b is if the B is there, I see a horizontal stretch or compression. And if B is less than 0, that's negative, then I see a reflection across the y-axis. Okay, so I see a reflection across the y. My H is still my horizontal transition, my left or my right. And because it is inside and under the square root, it is deceiving me. So to move to the left is plus, and to move to the right is minus. And then, of course, I see my plus k at the end, and this is my up, which is plus, or my down, which is minus. Let's go ahead and take a look at this function that we had at the top. So notice there is no a value, so I would call that 1. Okay. There was no b, right? There's no b value right here, so I would go ahead and call that 1. Here is my H value right here. It looks like -2, but it's really +2. And then, of course, right here is my K value, and it is +5. The last thing that we need to look at on this graph is our domain and our range, Everything is starting from this point right here. Everything is starting from this point right here, which is the ordered pair 2, 3. Okay, everything is happening right here from 2, 3. I'm going to go ahead and actually write that next to it, because this is going to help me do my domain and my range. Remember that the first number is always your X value and the second number is always your Y value. Okay, so what's happening to my X's? Well, they're starting right here, and then the graph goes in this direction forever and ever. So if I pull that to the X axis, it's starting right here and going onward. Okay, so this is how Alex wants you to write the domain. X is greater than or equal to 2. Or you could write it in interval notation, 2, infinity. Okay, but Alex wants it written X is greater than or equal to 2. All right, the range, what's happening with my range? Well, it's starting right here, and then the graph is going in this direction. So if I pull that to the y-axis, I go here, and I go up forever and ever to positive infinity. So my range, I can think of it as y is greater than or equal to 3, or in interval notation, 3, infinity. We have one last graph to look at. We're going to talk about its A, B, H, and K values and its domain and range. So here is my graph, negative x minus 2, the square root, negative the square root of x minus 2 plus 3. So let's go ahead and go into Desmos and graph that. Let's get rid of this function. Negative square root x minus 2, get out of the under the square root, plus 3. There it is. We want to have this leftmost point, and it appears, it looks like it's there at 2, 3. So I'm going to go ahead and I'm going to get rid of this stuff that Desmos has put in for me. And once again, I've already played around, and so I kind of know what I should see for my 4 points. So there's 2, and then 3, and then 6, and then 11. There we go, and then 11. So let me quick write that down. So it's 2, 3, 3, 2, 6, 1, 11, 0. So this time it's going down, but that's because it's going downward this time, and that's because of the negative. So the y's are decreased, the y values are decreasing this time, but that's simply because we have that negative in front of our square root. All right, let's go ahead and fill in. Here is my leftmost point, 2, 3. Then it's 3, 2. And then the next one is 6, 1, and then 11, 0, which is off my graph. So something like that. Oop, nope. Something like that. All right, my A value, I can see it right here. My A value is -1. My B value, there's nothing right here next to the X, so I'm going to go ahead and call it 1. That's why it's not really stretching or compressing or flipping it over the y-axis. My H value, be careful with your H value. It looks like it's -2, but it's really +2. And my K value is right here, +3. Let's go ahead and do the domain and the range. The domain and the range go right from your leftmost point, right here at 2 comma 3. Your domain, remember, are your x values. So you're going to take this point and pull it down to the x-axis. The graph goes in this direction, so it's heading towards all these numbers right here. If I were to pull each one of them down, they would come right down, start here, and then they would keep going in this direction. So I would say x is greater than or equal to 2. That is exactly how Alex is going to want you to write it. Or you could use interval notation, just like before, 2 comma the square infinity. Okay, because the 2 is included, it is a point on my graph, I want to go ahead and use the bracket, and then since infinity is not a definite point, it would use a parentheses. All right, let's do the range. So the range is the y. I'm going to take this point and I'm going to pull it over to the y-axis. And I notice that the graph is down here. The graph goes in this direction. So I have y is less than or equal to 3 because all these numbers here going down, I can see are less than all these negatives right here. Or I could write it as, no, negative infinity, comma, 3.